All right, so let's talk about this. If we find the distance between 2 points, we've got two options. We can use the distance formula, or we could use the Pythagorean theorem, because the distance formula really is just another version or another way to write the Pythagorean theorem. So how many of y'all use the distance formula? Okay, and how many use Pythagorean theorem? No one really? Okay, well, we're going to look at it both ways because I think Pythagorean theorem is going to end up being easier for some of the problems we're going to do. Okay? So if you used your distance formula, you would have had 4 minus 2 squared plus 5 minus 4 squared, which would have given you the square root of 2 squared, which is 4, and 1 squared, which is 1. So the square root of 4 plus 1 is the square root of 5. Is everyone okay with that? Okay, let's think about it using Pythagorean theorem. So for Pythagorean theorem, you would basically plot your 2 points. Okay, so you'd have your point at 2, 4, and you'd have your point at 4, 5. And what you do is you kind of visualize creating a right triangle. So you connect your 2 points that you're finding the distance between, and then you kind of extend out horizontally and vertically to create your right triangle. Okay, so think about it. The horizontal leg would basically just be the change in your x's, right? We started at an x value of 2 and we went to an x value of 4. So what did this become? This side length would be 2. Do y'all see that? Here, we end with a y value of 5. What y value did we start with? 4. So what's the distance between this? 1. And then we could call this c or x or whatever we want to call it. And then it's a squared plus b squared equals c squared or x squared. 1 squared is 1, 2 squared is 4. So then we get the square root of 5 is x. Why don't I have to put plus or minus the square root of 5? Yes, it's a length, right? We're only talking about a length. Okay, so sometimes this can be easier. When we are moving forward into circles, we're going to need to have something squared a lot of times, so you can really stop at this step. So it kind of saves you a little bit of time. Okay? All right, so today we are diving into circles. If you do not already have out your yellow formula, or not formula chart, but what's it called? The chart for all the different conic sections. We're going to add the real world, the formal definition in just a minute. What were some of the real life examples that we came up with for a circle? A wheel. Good. You should be able to generate real world examples of each of the conics. Okay, that's going to show up on quizzes and tests. If you don't already have that in your chart, make sure you do. All right, so here's my cone. How do I intersect this cone in order to create a circle? A plane that is parallel to the base. Okay, and remember I told you that you can kind of envision the altitude of this cone as what we call an axis. What would we say the plane is in relation to that axis? Yeah, or you could say perpendicular to the axis. I'm telling you both ways because you could see the problems come up both ways. Okay, so the formal definition of a circle is the set of all points that are equidistant from a fixed point. What does that word equidistant mean? Yeah, the distance stays the same, right? So think about your circle. Well, that's a really bad circle. Let's try again. Oh, well, that's better. Okay. So this equal distance from a fixed point. What is the fixed point representing, do you think?
The center.
Yeah, the fixed point is representing the center of the circle. And we will represent the center with C. Groundbreaking, I know. Okay, so then what do you think this equal distance is that we're talking about?
The radius.
The radius, yeah. Every point on the circle is the same distance from the center. And that distance is the radius. Everyone agree with that? Okay, so we're going to come up with the formula for our circle. So I'm going to draw myself another circle. And I'm going to label the center H, K. If I pick any random point on the circle, any point XY, we know that the distance between that point XY and the center has to always be the same, right? No matter if I put the point here, 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 no matter where. All right. So the way we could find that, okay, is the distance formula for R, or for between these 2 points, and that will give us the radius. Okay, so to find the change in, sorry, I'm going to draw my little right triangle. So my X values have gone from H to X, right? So I can say that the change in my X values would be X minus H. That would be this length. This is R. What would this difference be? Y minus K. So if we do Pythagorean theorem, we would have X minus H squared plus what? Y minus K squared is equal to what? R squared. That is the equation of every circle. So it's really just using the distance formula and showing that every point, now HK is a fixed point, that's your center. X and Y represent all the other points around. So just rewritten again, this is called the standard form of a circle. X minus H squared plus Y minus K squared is equal to R squared. The center is represented by H comma K. And the radius is represented by R. Okay? So for these two examples, we're going to find the center and the radius and then kind of sketch our graph. Okay? So look at number 1. We have x squared plus y squared equals 36. What do you think the center is going to be? Almost. But it's an ordered pair. It's going to be 0, 0. Because wouldn't you agree that this is the same as x minus 0 squared plus y minus 0 squared? Those are the same thing, right? So our center then would be at 0, 0. And what would our radius be? Is it 36? It's 6. Good, because we take the square root of 36, which is 6. All right, so if we want to just sketch a real basic graph of this, you would plot your center, and then you'd basically count your radius units in each direction, up, down, left, right. You can definitely approximate. And then it's really hard, but do your best to make a roundish looking figure. I'm not very good at it. Everyone okay with that? Okay, let's try number 2. We have x minus 4 squared plus y plus 5 squared is equal to 25. Okay, now remember when we did transformations, anything inside the parentheses was opposite of what you thought, right? So the center, very good. The center is at positive 4, negative 5, because you take the opposite of these signs. Okay? Your center would be at positive 4, negative 5. Everyone okay with that? All right, what would our radius be? 5. All right, let's just sketch a little graph. And obviously, if you had a grid, you would actually count the points, right? All right, everyone okay with the basics? All right. You're not always going to be given your equation already in standard form. Okay, just like with quadratics, if we were given to us an ax squared plus bx plus c, a lot of times when we graph, we wanted to turn it into vertex form. What process did we use to turn a standard form into vertex form? Completing the square. Okay, we are going to use completing the square again throughout this unit. Okay, so if your equation is not already in standard form, we're going to use completing the square. And at some point when you'll have a break, make sure you fill in the formal definition on your yellow card. All right, so we're given x squared plus 6x plus y squared plus 8y is equal to 24. And hang on one second, I'm noticing I might have it. Nope. Sorry, I was reading two different ones. X squared plus 6x plus y squared plus 8y equals 15. Sorry. Okay, the first thing you do is you make sure your x's are grouped together, your y's are grouped together, and your constant value is on the other side of the equal sign. So far, so good, right? Okay. The next thing we're going to do is we're going to set up completing the square. Now remember our goal. Our goal is to get x minus h squared plus y minus k squared equals r squared. So remember, the square in completing the square means a binomial that's being squared, right? So we're going to have to complete the square not once, but twice. Once for the x's and once for the y's, right? So we're going to set it up just like we're used to. So I'm going to deal with the x's, and then I'm going to deal with the y's. But I'm going to go ahead and put my blanks in. So I'm going to have x squared plus 6x plus blank. Now I'll tell you one difference. When we counteract this time, we're going to counteract over here. Because notice that's the only place we want a constant, right? We don't want a plus k over here like we did in vertex form. So we're also going to have, for the y's, we will have y plus y squared plus 8y plus another blank to complete that square. And then how many times are we going to have to counteract over here? Twice, once for each blank. Okay, so you kind of see where we're heading? All right, so let's start with the x's. I'm going to start by completing the square. So which value do I take?
6.
The 6. Good. I take my b value. I half it. I get 3. Box it. Square it. What do I get? 9. Okay. I write it. And then this time I'm going to counteract it over here. If I were to counteract it on this side, I'd put a minus 9, right? But if I counteract on the opposite side, I have to do exactly what I did. So counteracting it over here, I'm going to add 9. Does that make sense? Because we put 9 in on the left side, so we have to balance it out with 9 on the right side. Earlier with vertex form, we were putting both on the same side, right? So we did plus 9 minus 9 to make it 0. But now we're putting weights on either side to balance it out. Does that make sense? Okay. Okay, let's finish our x's. What does this turn into? Good. All right, ready for the y's? We do it again. Take your b value. What's our b value? 8. Half it. What do we get? 4. Box it, square it, and we get 16. We're going to write it. And then how do we counteract it? 16 to the other side. All right, what is this one going to turn into? Good. Y plus 4 squared. Don't forget that there is a plus sign in between your x binomial and your y binomial. Okay? And then let's see what we get over here. 15 plus 9 plus 16. What's that going to give me? 40. Okay, so now we are in standard form. What were our instructions at the beginning of the problem? Good, find the center and the radius. So now can we do that from this form? Yeah, what's our center? Good, -3, -4. And what's our radius? Good, so you would start with the square root of 40, but you do want to simplify that. So that's 4 times 10, so that would give us 2 radical 10. How are we doing? We okay? Let's try again. (4x squared plus 4y squared plus 16x minus 8y equals 24). Okay, so the first thing I might notice here is that all of those coefficients and constants are divisible by what? They're all divisible by 4. Remember that when we complete the square, the coefficient of x squared or y squared has to be positive 1. So if you can get rid of the coefficients to make your life easier, definitely do it. So I'm going to just start right off the top, and I'm going to divide everything here by 4. Now it's going to give me smaller numbers, and it's going to save me time. So check for that. All right, so that gives me x squared plus y squared plus what? Plus 4x minus 2y is equal to 6. Okay. Now we've got to get it organized so that we can start completing the square. So what did I tell you we had to do? Yeah, get your x's together and get your y's together. Be careful with your signs. So this would be x squared plus 4x. And we'd have plus y squared minus 2y is equal to 6. Are we okay with that? Are we ready to complete the square now? All right, so let's set it up. We're going to have x squared plus 4x. Then we've got to add something in. We're going to have y squared minus 2y is equal to 6. Why do I have 2 blanks on the side with the 6? Yeah, we have to counteract twice, right? We have to balance out twice. Okay, so let's go ahead and try. Take your 4, half it, what do we get? 2, box it, square it, and we get, so I'm going to add a 4 here, and then I have to add a 4 here. Yeah? Okay. Go ahead and finish this, get it into standard form. Find your center and find your radius. All right, so where was your center? -2, 1. Make sure you made this one a minus 1. Because when we take our b value here, it's -2. So when we half it, it's -1. Everyone okay with that? And what would our radius be? Yeah, square root of 11. Questions on that one? Okay, now we're going to work backwards a little bit. I'm going to give you some information about a circle, and I need you to give me the equation. Okay? You'll always give the equation in standard form. You do not have to multiply it out like those ones look like. You'll always leave it as x minus h squared plus y minus k squared equals r squared. All right, so the first one's pretty straightforward. We're given a center at 2, 0, and we're given a radius of 4. So how could I label my center? What do those numbers represent?
-2.
Okay, they represent h and k, right? So when I plug in to my equation, I got to think about what I'm doing. So I'm going to have x minus 2 squared. Everyone okay with that? Plus what? You can write y minus 0 squared, or you can just write y squared. Either is okay. Is equal to what? 16. Do not leave 4 squared there, because you know how to square that. Okay? You'll go ahead and write in the radius squared. All right, look at number 6. This time we are given a center at 5, -2. And we're given a point on the circle at 0, 4. What information do we still need in order to write our equation? The radius. So we need to find our radius. Okay, so let's think about what this looks like. I have a center at 5, -2. That would be my center. And I have a point at 0, 4. So I'm going to draw this really lightly, but do you see that that means that the circle goes something like this? Okay, and what we need to find is the radius. Well, that's pretty much exactly what we practiced at the beginning of the day, right? You can either use the distance formula or you can use Pythagorean theorem. The reason I recommend Pythagorean theorem is notice what you want in your equation. You want r squared. Pythagorean theorem gives you r squared. Okay? If you use the distance formula, that's fine. You just have to remember to square it afterwards. Okay? So I'm going to go ahead and practice with Pythagorean theorem. I'm going to kind of complete my little right triangle here. What would my horizontal leg be? 5. And what would my vertical leg be? 6. All right, so r squared equals 5 squared plus 6 squared. 5 squared is 25, 6 squared, 36. What do I get when I add those? 61. Do I have to go any further and get r? No, you haven't been asked for r. You've been asked for the equation. So now I can go ahead and just write my equation. What would it be? X minus y, 5 squared plus y plus 2 squared is equal to what? 61. Questions on that one? Okay? All right, look at number 7. Write the equation of a circle that has endpoints of its diameter at 7, 2, and -1, -4. Okay, talk to me about our strategy here. Huh? Okay, we're going to have to find the radius, right? One way is to find the distance between these 2 points and divide it by 2. Okay, what else do we need to find? Okay, what's the midpoint going to give us? Yeah, we need to find the midpoint of this to get our center. I would recommend finding the center, and then you could find the radius with one of the other points. You can definitely find the distance and divide by 2 as well. There's a lot of different options here. First, let's go ahead and find our center. So to find the center, we need to use what? Yeah, we need to find the midpoint of the diameter. So the midpoint formula is the average of your x's and then the average of your y's. So let's try that. We would do 7 plus negative 1 over 2 and 2 plus negative 4 over 2. All right, so I'd get 6 over 2, which is 3, and negative 2 over 2, which is negative 1. So what did I just find here? The center. All right, now you find the radius. You can either find the total distance of the diameter and divide by 2, or you can now work it like we did number 6, because we have the center, and you can pick one of these points and do it just like we did number 6. So go ahead and find your radius and come up with the equation of this problem. What kind of right triangle does this end up being for those of you that did it this way? 3, 4, 5. That's another reason that Pythagorean theorem saves you time sometimes, is that if you remember some of your Pythagorean triples, it can save you time. So r is 5, meaning r squared is what? 25. All right, so let's write our equation. What are we going to have? Plus, good, equals. Questions? All right, number 8. Center is at 6, negative 3, and the circle is tangent to the x-axis. Okay, now when you hear the word tangent, you might think back to geometry, and you might think of two things. You might think of the trig function tangent, but what we're talking about here is the circle, when we learned about circles. So what do you remember about when you talked about circles with the word tangent? Good. It's a line that touches your circle in how many spots? Exactly 1. It's really hard to draw. Right? It's a line that touches your circle in exactly 1 spot. All right. So let's see what this is saying. We have a center at 6, negative 3. And it tells me that my circle is tangent to the x-axis. So that means that I have to have one point where? On the x-axis, which would end up being at 6, 0. Okay? If I tried to kind of go anywhere else, it would end up giving you 2 points on the x-axis. Okay? So your circle kind of looks like this then. Do y'all see that? So what does that tell me then? Good. That tells me that my radius is 3. All right, go ahead and write your equation. All right, what would our equation be?
X minus 6 squared plus y plus 3 squared equals 9.
Double check your equation real quick. Make sure that you have both of your squares. Make sure you have both of your squares, okay? Make sure that you also have this plus sign in between. Make sure you've got your r squared. Those are all things that you could lose little points for that you don't want to, okay?
Is it always gonna be plus in between?
For circles, yes. Other questions? Okay, go back to your yellow form if you haven't already, and make sure you have your formal definition on there. A circle is the set of all points equidistant from a fixed point. Or did yours say such that? Yeah. So you would say the set of all points such that the points are equidistant from a fixed point.